Hello, everyone, and thanks so much to Matt and JD and everyone for running this show again virtually. Super excited to be able to do this, even though we're not in Vancouver this time. So my name's Tim Sutton. I work at Square on the Mac Compute / mobile developer experience team, and I look after, along with them, the continuous integration infrastructure at Square for iOS development. And so what we're going to get into today is the state of Python on macOS in 2020. So let's get started. So this talk is really aimed at anyone who is, whether you're developing Python tools, but also if you make use of any Python code really whatsoever in the context of managing Macs, deploying code to other systems. So this should be equally interesting for you if you work actively on any of like the MacAdmin Python-based tools, or if you are more of a user of them. And I'll just preface this whole talk with the fact that everyone's environments and needs are different enough that I'm not going to recommend one specific approach here, but this is really just in 30 minutes, sort of tip of the iceberg to point you in a few different directions. And there's also aspects of this that are applicable outside of macOS too. So in managing systems, even though we're going to be talking a lot about like Python and some Python internals, our goal is not to write, the best Python deployer or the best Python installer or the best Python management tool. Our goal is really to run code on some machines in order to accomplish some task. So the rest of this I see as just a vehicle to get there. So in a scenario where we have an interpreted runtime or an interpreted language like Python, same thing goes for like Ruby or Node. Same general problems is that we have Python itself and the standard library, code that it needs to run. In Python, we probably will have to be aware of which package it's using for crypto functions, and that will be usually an issue when it comes to making like secure web connections and dealing with certificates and such. So the runtime is one piece of it. We may well be pulling in additional packages that our code sits on top of as well. Python Objective-C is one common one. Requests is another one. So we might be using something beyond the standard library. And then the actual code that we want to run in the first place is obviously a part of this as well. So we really need all three of these things to be taken into account in terms of how we get code onto another machine in a way that it's going to work the way we expect. And so why are we talking about this now in 2020? We've had Python around for a long time, but what is kind of different at this point? So there's a few things. So one is that Python 2 was always built into macOS. You couldn't install OS X without getting a copy of Python. So this made it very convenient for bootstrapping systems. You could always rely on Python being there. At the earliest stage, you could possibly need it. And Apple also included Python Objective-C with that Python. So it was functional for anything that we would want to rely on Apple frameworks, potentially, in our Python code. There was also, in the earlier days, not really such an issue with making secure HTTPS connections to websites. And it started to become problematic for a while as Python was linked against a very old version of OpenSSL. But in the early days, this wasn't really a problem. We didn't really have to, I think, worry too much about what OpenSSL library, for example, our Python came with. But these days, that's definitely part of a concern. And then I think the biggest reason why this didn't used to be an issue was that Python 2 was a viable version of Python to develop in. Now, if we go back a bit, Python 2.7 shipped with OS 10 for the first time in Mac OS 10 Lion. And that was 9 years ago, and the world was pretty different 9 years ago. 9 years ago, Swift was years away from even being announced for the first time. We didn't really know or use widely newer languages like Golang, for example. And Apple's website and the marketing materials looked like this, which was very different than they look now. So now, Apple's marketing materials look like this. And I thought it was funny that you can actually go on Apple's store and you can still purchase a copy of OS 10 Lion today for looks like $28 Canadian plus tax. Unfortunately, I thought that this was originally the USB stick installer that Apple used to sell on the store for Lion, but then I later found out that that actually used to cost $70 or something. So anyway, I thought that that was funny that you can still buy a copy of Lion and Mountain Lion today on the Apple Store 9 years later. But fast forward back into today, on Catalina, Apple did officially finally deprecate 2.7 with part of their release notes explaining that the scripting language runtimes are now just a legacy compatibility thing. They're not future versions will not include them. And it's not just a warning in the release notes, but on a Catalina system, if I type Python, I'm going to get a stern warning that it's not recommended, and instead, sort of ambiguously, suggests that I transition to using Python 3 from within terminal. So if I go to the same Catalina terminal and I type Python 3, it's going to call into user bin Python 3, and I'm going to actually get the familiar little developer tools installation prompt. So Python 3 is now part of the command line developer tools on Catalina, as well as Xcode. And it seems like actually that it's pretty cool that you can just get Python 3 in a few minutes on a system just by typing it. And it's going to be, I think, a modern 3.7 version of Python. You can actually look in a bit more closely at the package. So this is the executables package that I pulled from the software update server. This is what you would get if you type Python 3 and install the command line tools. And I'm just pointing out here where this sits within the package. So you have, within this command line tools folder here, you have sort of another developer hive alongside all the other developer tools. And this is where Apple's Python 3 framework lives. It's not even inconceivable that you could deploy Python 3 to some systems through the command line tools installations, although you might not necessarily want to do that. But it could be useful in cases where you have minimal needs and you might actually want their specific build of Python 3, for example. And then software update will be keeping that up to date. So that's just something to be aware of. But this was mostly just a curiosity to sort of see where it sits on the OS if you do the command line tools install. And then there's also a fun little Easter egg here. If you look inside the Python installation, you'll see a patches tarball. And this is a tarball containing all of Apple's source patches that they've applied to build this version of Python. And it's kind of curious because you'll see in here that they've modified some of their build tooling to support running Python on ARM, running Python on other targets such as iOS. So there's just some fun stuff you can look through in there, and that's just onto that's probably on a lot of your systems already. So how else can we install Python? We looked at Apple's installers as part of the command line tools, but if we really want to be more, purposefully installing Python, we probably want to get it from some other source. And so there's a couple of options. So python.org makes available standard macOS installer packages, binary packages. These packages also include an OpenSSL distribution that they bundle with it, so it's independent from your system, not going to necessarily change with your system. And then a second option, which we'll dive into a little bit, is Greg Nagel's relocatable-python script and build tools. And this is this relies on those python.org installers. So it repackages them in a particular way that we'll explain in a sec. So that's sort of what's some of the options available on the management side. For your own development, there's a few options. So if you are working in Python, in day-to-day on your own system, you can look at the PyEnv tool, which is a tool that will make it easy for you to install different builds of Python, different versions, and also switch between them very easily. So you can do things like set a global default version. You can override it specifically in your shell or per project. And you can use that in all of your virtual environments. You can customize the way that Python is built as well. So that's quite convenient for development purposes. And they won't install in system locations either. So it's very clean, sort of isolated install. It makes use of this Python build standalone project here to do the Python building part. But this project is also its own standalone tool that you can use to just build a Python runtime. And then the last is obviously Homebrew is another common way to get Python onto a system. Python is actually a dependency of a lot of other Homebrew packages. So I think almost anybody who has installed things with Homebrew probably already has a distribution of Python 3 on their system through Homebrew. It's a convenient way to get Python on a system, although it doesn't give you a lot of control or flexibility over where your packages are going to go out of the box, or you're not going to have ability to conveniently switch between different versions very easily. It's not really what Homebrew is designed to do. So, and probably not so suitable for like mass deployment either. So python.org packages, those just come straight from their website. You can download them. If we take a look inside the package, it's a fairly standard safe installer package. It puts a python.framework file inside of library frameworks. I think the one thing that's worth mentioning here, besides the fact that it does include its own OpenSSL distribution, is that it places all these symlinks inside the user local bin directory. And anybody who has used Homebrew or has dealt with systems that have Brew installed on them knows that this is also an area that Homebrew sort of claims to put a lot of its own symlinks in. So I would suspect that if you were thinking to use this package on systems that might have Homebrew or other internal management tools, it might be problematic that you have this mixed in. But it's also, I think, possible to one could just take the framework and this Python app bundle separately from the package and just not install the symlinks. But I think that if you were going to go to the lengths of modifying the python.org package, I think you're probably better off looking at Greg Nagel's relocatable Python package or relocatable Python tools instead. And so Greg had started down this path when he was looking to embed the Imager app, which uses Python, into the recovery partition. And what's fun is that nowadays, that's still a common scenario with Tukanew's MDS tool, which runs Imager from the recovery partition. And so what Greg did is he found a way to take the distribution from python.org and take that framework file and basically run through all of the libraries inside it and executables and relink them in such a way that they link to each other relatively instead of through just the absolute path of the installer. And what that gives you is a Python that is easy to put anywhere else on the file system that you want. And another nice thing that Greg added is the ability for it to install extra pip packages as part of this build. So by default, it will actually include Python Objective-C and Xadder, just like Apple's Python 2 distribution always did. And since he built this, it's also been included as the Python distribution that is used by Monkey and AutoPackage. So basically, if you've used any of MDS, Imager, AutoPackage, or Monkey, which is probably quite a few of you, you're already using this. So it's been proven as a solution, at least in these scenarios. So I could imagine a scenario where you have your management system place this Python framework inside some path that you know belongs to sort of your own organization's stuff, and it's a path that you control, and then you can have tools pointing into that framework in the shebang. You could also add additional symlinks, you know, pointing back to it as well, to make this a bit more manageable. But the big advantage here is that you're explicitly defining which Python runtime any of your code is going to be using. And you're also able to include any dependency Python packages that you know you would need for those programs into your sort of master distribution here. So it makes it very resilient against a case where somebody might later install something like Brew, and for that to mess up or confuse which Python is going to get called, you know, when somebody, according to things like the default search path and such. So this is definitely a pretty, I think, could be a very useful solution. And I imagine there's probably already people who are deploying Python in this way, especially to get ahead of the days when Apple won't be including a Python anymore with the OS. So from there, I want to shift over to a different set of tools that also kind of go beyond the tools that we're aware of, like in the MacAdmins community. And I want to talk about a set of tools that are also trying to solve the packaging and distribution problem. And these are ones that can compile everything that we need down to a single binary. So you know, all of these are, from what I could see, one of their goals at least is, you know, I have some Python code. I want to be able to give that to somebody else that I don't know, or I don't manage their systems. I just want to give them a link to be able to download something and run something, and it's going to work. And so one of the solutions for that is called PyInstaller. Been around about 15 years. It's fairly straightforward as far as ease of use. It takes your Python as a shared library. It walks your code to figure out which modules it thinks it's going to need. It can also do some extra clever things like making a .app bundle. It can add extra resources on Windows. It's really quite an elegant solution for packaging and a clever way of like packing your whole program into a single binary. And it also doesn't recompile anything. So in that sense, I think it's more portable, or it's more, I think, generally compatible with different code bases. There's a couple other solutions as well. One of them is called Nutka. And this has also been around for quite a while. It is a full-on Python compiler. So it's more about creating an optimized binary of your Python code through actual recompilation. So it differs from PyInstaller quite a bit in that way. I think in general, it's also less compatible in the kind of the ecosystem of different Python packages. And then there's a third solution called PyOxidizer, which is relatively new. And it's actually written in Rust. So it's installed via Rust package managers instead, which are easy to get installed and get going with. And it embeds Python as a runtime into a Rust program. And gives you a similar set of tools for being able to customize how that package looks and how it's laid out. This one is, I think, maybe the hardest to get started with, but because it's also the newest, that's understandable. So 3 different solutions, quite interesting. I'm going to look more into the first one. So I first tried out PyInstaller a long time ago when I wrote a tool called Brigadier, which I wanted to run on Windows systems. And I needed to have it run on Windows systems very early before I had any management tools, or I didn't want to install Python distribution. So I was able to use PyInstaller to convert my script into a 4 megabyte executable. And this morning, right before this presentation, I was I dug up some IRC logs that I had from the old OS X server channel. And I know now why I got the idea from Michael Lin, because when I grepped my IRC logs for PyInstaller, literally every single message is from Michael Lin telling everyone how awesome PyInstaller is. So, so hat tip to Michael Lin for sharing that with me, because it's been something that I've enjoyed using ever since. So we are going to jump into a demo of PyInstaller now. And what I'm going to use as my sort of demo app is a command line tool that I wrote a number of years ago called Custom Display Profiles. And I thought that this was a good candidate because it was written for Python 2, Apple's Python 2. It does use Objective-C, so you know, that it kind of ticks the box for something that I would need probably in other circumstances as well. And otherwise, it's a fairly straightforward use of Python Objective-C. So it's not too complicated. I figured it would be a good candidate for trying this out. And so I've got my code here. The only real change I made, besides a couple of things to make it Python 3 compatible, is I also changed the shebang just so that it could run with any version of Python. So the Python that I have on this system is, or that I'm using right now anyway, is Python 3.8. And this came from pyenv. It was built with pyenv. So if I were to just use this Python to call the script, it's not going to work at all because I don't have Python Objective-C available to this Python right now. So in order to give myself a workspace to install what I'm going to need to build this, I'm going to create a new virtual env. And I'm going to call it MDO demo. And then I'm going to activate that. This is just a pretty standard virtual env activation process, which is just going to give me a sandbox that I can install things into. So now I can do pip, if I can type pip install PyObjective-C. That's going to go and pull in a whole bunch of different framework packages that will allow Python Objective-C modules to work. And so now if I try my Python command again, Python custom display profiles, now works, right? I can call the program. It can work. So the second thing I need to do is, of course, I need to install PyInstaller itself. And I'm going to do that via pip install command that I grabbed from my clipboard here. Now, the only reason I'm not just doing pip install PyInstaller is because there's a bug that I ran into from the current release that was affecting Python 3. And I really wanted to use Python 3 for this. So I'm installing basically from master. PyInstaller 4.0 is scheduled to be released this month. So I'm just sort of getting ahead of it. So now that we've got PyInstaller, all we need to do to build this is just one command where we say PyInstaller custom display profiles. And I'm going to pass it this argument called one file. And that's going to tell it to build one static binary. And so what it's going to do is it's going to look at my file. It's going to scan all the modules that it thinks it's going to import, go through recursively. You can see here it's going to use this particular Python shared library that I have in my distribution. It's going to archive all the stuff that it pulled in that it decided that it was going to bundle up. And it's going to build a self-extracting archive and add a little bootloader to the front of it. So that way, when I run this program, it's going to be able to execute and have access to all of the things that it needs. And it's going to put stuff into a dist directory. And so we'll see I've got this one binary that is 7 megs. So I don't want to test this out on my own system because I've already got Python and everything installed. I want to test this on a system that that doesn't have anything available to it, right? So I've got a Mojave VM, so it's also a different OS version. I have Catalina here building it, Mojave to run it. I've got no Python 3. I do still have Python 2, though, and I think it'd be more fun if I pretended that I didn't have any Python at all. Just pretend this is the future where there's no Python in the system. So let's go crazy and just wipe Python off the face of the earth on this VM, which is easy to do when you have a VM. So I'm going to copy this file over to my VM. And so yeah, here in my desktop folder, I don't have anything, I don't think. No. And I'm going to copy that guy over. So now when I run custom display profiles, we'll see if our app worked. And it did. So without any Python on the system and just one 7 meg executable, I was able to still get my script to run. And I want to really make sure that it works properly. So I'm going to actually try it out and do what it's meant to do, which is to let me apply a color profile. And so I'll pick this profile here, and we'll see that maybe it doesn't come across so well as a demo because it's just shifting the color. But if we look also in my display preferences here, we'll see that the color profile did in fact change. So that's basically just a demo of what you can do with PyInstaller. One extra thing you can do if you don't do the one file option, it's going to work the same way, except that it's not going to archive the entire, all the Python modules into one file. And it's kind of interesting to take a look at what it builds in that case, because here you'll see basically everything that it had to include. So if you look inside here, we've got a lot of these files are all just part of the Python standard library. But what's cool is that even though my my virtual environment had all of this Python Objective-C, all these different wrappers for the different frameworks, PyInstaller was able to determine that the only one of those, well, a few that I needed were like Foundation. It needed, a core Objective-C module, but then it only picked out Quartz because Quartz is what's being used to do the color sync APIs. So that just goes to show that it is able to walk through and figure out what it needs from your code. So I'll just hop back into the presentation. Mention a couple of quick caveats with PyInstaller. One is that you do need a Python that has shared library as support. And so that's pretty straightforward. With PyEnv, it's just a matter of passing an extra build flag. I think it should be possible to use the framework builds as well. I just didn't have any luck doing that. But because PyEnv worked for me and it's what I use anyway, I just stuck with that. And then the other difference is that PyInstaller is going to take your archive, unpack that thing to disk, and then run it off of like a temporary directory. So I think for almost all the use cases, that's fine because the startup time is still very fast. But it's worth mentioning just in case you were writing something that you actually needed to call it and like get the results back really, really fast. It's not as fast as a solution that would really truly compile your code down to an exe through a native compiler. And I think we're running towards the end of time here, but a couple of things I wanted to just add about how to find out more information about your Python distribution, and in particular, things that are related to OpenSSL libraries. So there's a module called sysconfig, which is part of the standard library. And you can use this to get all the build and configuration arguments from your Python installation. And there's way more than I'm showing on this slide. I just happened to highlight the ones that are related to OpenSSL. So this is very useful if you're ever trying to diagnose an issue, especially around OpenSSL and your particular Python distribution, because you can see what flags were used to build it. And the fact that this is also a module available to Python code, you could use this in your program to make it more adaptable to the environment that it's running in if you're building something that is meant for more general consumption. Other SSL config stuff, there's the SSL library, or the SSL module also exposes the SSL version. You can look that up yourself. This is from the python.org distribution, from the python.org installer. You can see also, you can use the otool command with -l to tell it to show you shared libraries that are linked to from that binary. So in this case, we can see that it's linking to the absolute path at /library frameworks Python, and we can see it linking to the two different SSL dynamic libraries there that the python.org installer includes. If we run the same thing from Apple's Python, we can see it's linked against LibreSSL instead. And we can see that it's linked against their own Apple's internal security frameworks rather than a standalone distribution of OpenSSL. I think that there's a whole other talk that could be done around SSL things with Python. And just a couple of things to mention, that if you're doing anything to do with certificate auth or internal sites that need their own root certificates trusted, you're probably going to need to know which trust store is being used by your Python. If you're using requests, then your request is going to use the certify package to put down a set of known root certificates, and you might have to do some extra work in order to tell it where yours live. And then the last bullet there on the bottom is the Homebrew OpenSSL installer has a cool example of when you install OpenSSL with Brew, it's actually going to go through your keychain, and it shows how to take known roots out of the keychain and put them into a PEM file. And so that could be useful if you have a setup that works with roots that are trusted in the keychain, and you're trying to migrate those out to a location that you can use with a Python that was built not by Apple, not looking at the keychain. So that is finally to wrap this up. And thanks so much to everyone for running this. There's also a link at the bottom there to my blog, and there's links in that post to everything we talked about today.